Hello class. Um, this session involves taking a look at two different topics which taken together will enable you to program an internet client and also program an internet server. So here we go. At the end of the day, you should be quite an expert in this particular field of computer science. So what we're looking at is the programming problem involved in allowing uh, a laptop or a machine or a desktop computer to communicate with uh, a remote version of a laptop or a machine or whatever through the internet. And if you notice the bidirectionality of these two arrows, I want to enable A to talk to B and B to talk to A bidirectionally, or in TCP terms, I want to use TCP's duplex capability. And of course, what's going on here is that on machine A, some application using TCP is running, and ditto for machine B. And the idea is that both A and B are going to communicate with one another using dedicated ports. So A is communicating on a particular port, and as far as A is concerned, uh, data communications have to go to machine B's address, which consists of two things: an IP address and a port number, and vice versa. B is going to talk to A on a particular port, on a particular IP address. This machine has got an IP address, and both machines are capable of supporting many hundreds, if not thousands, of different applications and processes, and they can be distinguished between the port number that they are listening on or receiving data on. So we'll take it from there. That seems easily enough. So, so it's required to allow A to communicate with B. And here I'm showing you the two sockets. There's a socket, there's a socket. B, the application on B has created a socket. The application running on A has created a socket. And to create a socket is extremely easy in Java. So if we learn a bit of Java, then we can actually create a socket that can connect with its counterpart on remote machine B. And I hope you're impressed with the simplicity with which and the ease with which that's done. So what exactly is a socket? I have no idea why a socket is called a socket, but it might be worth spending a minute or two just finding out the derivation of the word socket and why it's used. But you can think of a socket in true object-oriented spirit as an object that has been assigned an IP address and a port number. And as I said earlier, a socket will typically be hosted by an application running on a particular host. So that's clear enough. So wait a minute, I've got the same page there. So to connect to a host, what we need to do is to specify the port to connect to. And again, it's going to be a TCP connection, which we spent quite a lot of time getting to understand by means of this three-way exchange of quite special packets. And I want, if nothing else, at the end of the day, I want you to really understand how a client can talk to a server after it's created a TCP connection. So that's quite important. But it's not, the details of that aren't important here. So I'm assuming that the server is actually already running on the remote machine on a given port. If there isn't, then the attempt to make a connection obviously, or perhaps not obviously, will fail. I mean, it's going to fail because it can't do this handshake that's necessary. And in that case, on the client side, what's called an exception will be thrown in attempting to create the socket, because the socket is absolutely a key part of creating the connection. And I don't know whether you remember, but I've got a small presentation on objects, and the last thing I look at in that presentation is what exactly, well, not what exactly, but I've given you a brief, clear explanation of what an exception is. I mean, something going wrong, and Java is one of those languages that enables you to spot if anything bad has happened and then attempt to remedy or rectify the problem. I mean, rectification might simply be to let the user know that something's failed or something's gone wrong. And sometimes you can do something about the situation, sometimes you can't. I mean, for example, if you're running a program, an exception might be created if you run out of memory. Or, let me give you a very concrete example of something going wrong. Supposing a little bit of maths programming, actually, you didn't know it was going to happen, but the program actually attempts to compute the result of dividing 1 by 0. I mean, perhaps you don't realise that, but 1 divided by 0 is probably infinity, and I think any programming attempt to perform that division is going to result in a system, well, not a system crash, but a programming crash. So we're going to be interested in the endpoints. Well, a socket, you can think of, okay, a socket's got an address, and it's consisting of an IP address and a port number, but it also represents the two endpoints of an input stream and an output stream. Remember, a stream really is like a doorway, an indoor and an outdoor. From an input stream, I can actually read data, and on an output stream, I can actually write data. So a socket's important because an essential part of the structure of a socket involves streams, an input stream, getting an input stream, and getting an output stream. So let's take that a bit further. So here we go. So in Java, there's a class called socket, which we're going to create an instance of, as we'll see perhaps a bit later on. And it can take two parameters in what I call the constructor for this class. And I'll sort of spend a bit of time sort of explaining what a constructor is. It's a bit like a method, but a constructor doesn't return a value. It more or less does something. So it takes two parameters. It takes a string host name or an actual address in the form of four 32-bit numbers called a dotted decimal number, and a port. And this method is often marked as throwing an input out exception for the reason I've given you. I mean, maybe you try and create an instance, and I'll show you how to do that in a moment, but it doesn't work out and throws an IO exception, which you can attempt to catch. First of all, identify it, then handle the particular kind of exception that's been thrown. So here we go. I can write it's a very imaginative new word standing for the object I'm just about to create. It's sock, and sock is of type socket, and it results this instance, this object called sock. So it's I'm going to create an actual socket, and I write it's a new instance of this class, and I've plugged in the two parameters, for example port number 7979 and a particular remote machine IP address. So that's all quite straightforward in my mind, but you can get back to me if it's not fairly clear. Anyway, let's just move on a little bit. And the methods that come with a socket object, and actually defined in the class from which we've created it, are those that actually tell you, if you've forgotten, um, who the remote host that you're attempting to connect to, and it also tells you the local port that you're communicating on, and also the remote port that you're communicating with, as well as, so this is the critical bit, as well as it gives you methods to identify or extract two streams to allow outgoing and incoming communications. And again, just to remind you, a stream is a unidirectional entry point onto a communication channel like the internet or a wireless connection or whatever. So we need two of them because what we're looking for is duplex communications, two-way communication. So we need two streams to do that, to enable us to do that. So the two methods that come with a socket object are, first of all, the method GetInputStream. It doesn't take any parameters. All it does when you execute this is to return a particular stream. So the object that it returns is of type InputStream. And you're going to have to cast your mind back to the work that we did do on input streams. And a basic input stream is going to support something like a read integer, or at best it's going to be able to read an array of integers. And again, if you execute GetInputStream, apparently it can throw an IO exception, but we'll just ignore that for the time being. So the point of me showing you this is that executing a socket's GetInputStream method returns an input stream, and all data sent by the remote host can be read at the local host using the methods that come with the input stream. Right? The input stream in turn gives you some methods that allow you to retrieve data from the communication channel to which it's being connected. Well, the communication channel it's being connected to is the internet. Okay, so let me give you a very clear example of the use of all this. So I can say, well, perhaps I should say, oh no, that's okay. So ins, standing for input stream, and that's my name. It's the object I've just created. It's of type input stream, and it's assigned by executing GetInputStream, which is found in this object here, ASOC. Do you remember ASOC? ASOC is an instance of the socket class. I've just above a couple of slides ago, I showed you how to create an instance of a socket, and I called it ASOC, I think. I mean, I might be wrong, but anyway, what ASOC is, it's my name for the result of creating a socket. So that looks fine. Doesn't take any parameters. So here we go. Look, ins is going to stand for or represent the input stream I've just identified by using a sock to get it, literally to get it. So let's just move down the page. Right? So, and exactly the same thing aspect holds for an output stream. We can use the method called GetOutputStream, and if I want to use that method, I should really wrap it up with, well, try doing this and catch the IO exception, if it happens, by executing a little bit more code. I mean, that sounds a bit complicated, but it's not. And I'm going to give you a program that shows you the use of GetOutputStream in action in a moment. So very similar, in a similar fashion, GetOutputStream actually returns an output stream object. Sorry, an output stream, and it is an object. And when we've got an output stream, that allows us to write data across 20,000 miles to the remote host. Allows us to write data to the remote host. Well, okay, an output stream, a basic output stream, is going to allow us to write, to send either a byte or possibly, I can't remember offhand, or an array of bytes. And that's okay, but it's very low level. I mean, who wants to speak the language of bytes, as it were? So let's just move on a little bit. So for reasons of efficiency, we should think about buffering a socket stream, a stream that's been obtained from a socket. And just also remember, just going up a bit, I might as well say that if you want to use GetOutputStream, you have to write the name of a socket, like Chriskenberg socket, dot GetOutputStream, and I'm going to assign that to a variable of type output stream. So, okay, that sounds a bit of a mouthful, but it's actually very, very straightforward. And let's just move on. For reasons of efficiency, a socket stream should be buffered. What I mean by that is that supposing I wanted to send to you, member of my audience, Charles Dickens' it's quite an interesting novel, but it's quite lengthy as well. It's called Little Dorrit. It's a charming tale. If I can send it to you only byte by byte, that's going to be a very inefficient way of doing it, to communicate it to you. I mean, it's a bit like me speaking to you now. I mean, what if I could only transmit a letter at a time, the sound of a letter at a time, like a, u, t, p, u, t. Okay, I've just said output, the word output, and I'm transmitting it one character at a time. It's it's not useless, but it's a very inefficient way of talking. I'd much rather say output. What I'm doing, I'm buffering all those characters together and sending them out in one block. Output. Okay, the alternatives of that, we would actually end up transmitting millions, perhaps, of small packets containing just a byte. So I hope you see the point of my saying that. When we finished using a socket to communicate, we simply close it because we finished with it, and I want to tear it down. I want to reclaim the memory, perhaps, that it's been using for the duration of the communication. Just as a sort of bit of an obscure footnote, if the stream is the buffered stream, we close that rather than the stream that's being buffered. So perhaps I'll talk to you a little bit about that. It's not crucial at the moment. So there's a couple of there's a class called inetAddress, which allows us to obtain the IP address of the remote host, and maybe we'll have the opportunity of using GetInputStream if we've actually I mean, maybe I put it this way: supposing I'm the server and you just as a client, put in a request, I might be interested in finding out what your address is so that I can, do a bit of housework and start preparing for communication with you. I need to know who you are, i.e., what your address is and what port number they're using. And I could get the port number, the remote port number, by using just get port. Anyway, there's some utility methods at our disposal. Okay, so we have an opportunity of finding out about those and getting a bit of practice using those sort of quite soon. So the next thing I want to talk about is something called the server socket class. It's a specialized socket, and let me give you a little bit of a description about it. So whilst I can communicate to a socket, and you who are communicating on the socket can communicate to my socket, that's no problem. But sometimes it makes sense, and I'll tell you about why it makes a lot of good sense to use server socket if you're building a server. So a socket, listen to this, it's important. A socket, when a line involving the creation of a socket is used, a socket is going to make a connection to a remote port on which a server socket is listening. Right? So it's making a connection. In other words, even though we can't see it, it's all done in the background. A connection is being made with the server, between the client and the server. In other words, the three-way handshake takes place. Brilliant. We don't need to know about it. We don't see it. It's all happening in the background, out of sight. So supposing the server's listening on socket port number 100, then if the server socket accepts my request, what it's going to do is to create a unique socket for any further connection to take place with me, right? And critical idea here is that we're dealing with a server, and a server, as you probably realise, can accept hundreds of client requests within a very, very short space of time, or accept them concurrently. So the point is that another client might just come along and also request a connection at exactly the same internet address. I mean, it could be Microsoft.com port 80. It wants to access Microsoft's web server. Let's see what happens. Well, I'll show you what happens by means of this diagram. Here am I, client number 1, and I've got a particular port. Maybe it's port 99, and I'm establishing a connection with the server socket on, let's say, port 80. And if the server likes me and accepts my request for synchronization as a result of the three-way handshake, it will accept my request. And what that means is that it's going to create a one-off socket for me to continue to talk to the server on. And it's this socket that the server will send me everything I've requested. I mean, maybe it's my horoscope, or maybe it's a way of repairing an Alfa Romeo's engine management system, or maybe it's an update on the stock markets or whatever. All right. So the idea is that a socket will be created just for me to talk to me on. But if moments later, or very, very close in time, client 2 also requests a connection on the same port, and if the server now accepts client 2's request, the server socket will actually create a second unique socket on which the server can talk to me. So here we go. Sorry, it might be a bit difficult to track this, but the communication path is this. Look, can come back to me there. And ditto client number 3, 4. Maybe like the Microsoft server in, I think it's in, I don't know where it's based, Redmond, somewhere in the United States. I mean, maybe the web server can actually handle 10,000 clients in a short space of time, and it's going to handle them concurrently. And I might say a little word about that later on. So, just to wrap that up verbally, server socket creates a socket for each client connection by accepting the request. And what the server will do is simply to wait until a client puts in a request. So it's not going to do anything else. It's just waiting to accept a connection. When a request comes in, it'll start to execute, and as a result of executing, we'll create the socket. So it's just waiting, right? Afterwards, after a request has been accepted, the server can then extract or identify an input stream and an output stream from each socket that it's created and start communicating with the client. So it creates, the server creates a socket for me, Chris Kinberg. And the first thing it's going to do is to use that method, get an input stream and then get an output stream. Once it's got an input stream and an output stream, we're in business. It can talk to me because the input stream and the output stream are going to be connected to me and my socket, my input stream and my output stream. So that's okay, it's reasonable. So let me give you an example of how to create a server socket. So I'm giving an original, lovely, memorable name called server, lowercase. Its type is server socket, and it's a new server object created from the server socket class. And I can parameterize it. I can plug in 99 because as we'll find out, the constructor for server socket accepts, one of the things it might accept is an integer representing the port number on which to listen. So from that moment in time, if you execute this statement, the server will be listening continuously on port 99. And if that is the case, I can send the server a request, and if the server accepts the request, it will create a unique port to communicate with me on. Okay. So again, what the server code will do is to accept uses the accept method, which again you've got to wrap it up in a try accepting, try executing accept, and it might not happen. I mean, something might go wrong, so you've got to handle the problem. So the accept method waits until a client makes a connection on the port on which the server socket is listening. And a little example of that code, I mean, I think this is a lot easier to understand than an integral, some horrible algebraic expression that needs involving cough and shine to integrate. I mean, okay, so let's read this. Let's try and get some intuitive flavour of this. New client is the name of a socket that's being being returned by using server's method accept. What accept's going to do? If something or someone attempts to connect, will return a brand new socket, and I've given it a name, new client. It's a socket from which we can actually identify an incoming stream and an outgoing stream. So, believe it or not, just in a if we understand something like 4 or 5 lines of Java code, we've already have enough in our possession to establish internet communications. So the steps are very straightforward. First of all, you create a server socket on the remote host, listening on, say, some given ports, which you might advertise on television or radio or the papers. Come and get free legal advice. Come and visit Kinberg's legal assistance, and I'm listening particular address on port 500. And then to communicate with the server, you need to create a socket on the client side. And I've shown you how to connect to a remote host, and in particular, I've shown you how to connect to a remote host, in other words, a server, listening on a given port number. And all we now need to do is, on the server side, perform an accept method call to enable the server application to be able to communicate with me. So, a little note on what accept does, and I think we've probably said this already, but the method accept returns a socket from which the server can access the input and output stream attached to the client. And at that point in time, the server can then communicate with me. So we've established TCP internet communications. And okay, I mean, probably finished there, but I've raised some issues. Like I've told you, a server can have lots of different clients, and you might say, well, for goodness sake, how does that happen? Well, it's quite easy to spell out, but we just have to talk a little bit about concurrency, and the other thing is, okay, so I've explained what a socket is, I've explained what you can do with a socket, I've also explained what a server socket is, and I've explained what a server socket does when it accepts a request. And I've also made the point that when you create a socket and you connect to a remote host, you are in fact, in the background, you're actually relying on the three-way handshake to do the synchronization and all that the diagram I gave you involving 3 TCP segments, I think 2 or 3 weeks ago. So it all ties up. That's the theory behind it. So I'll finish here, and what I'm about to do is to give you some detailed code that will enable you to cut and paste, first of all, a client into Eclipse and run the client, and then cut and paste the code for the server and run the server and see them talk to one another. Remembering the fact that, okay, well, the server's actually running on the same machine that you're running the client, but they're running independently. And if the server runs on your machine, it could be running, I mean, in principle, it will work on some remote machine in Abu Dhabi or New York or Moscow. So I'll finish there. Now, hopefully this has been quite helpful. Okay.